And let's go to the problem of the day. Got a starter here. Wow, what is the perimeter? A word problem, friends. What is the perimeter of a rhombus if the diagonals are 24 inches and 32 inches each? Wow, what is the perimeter of a rhombus? Look at that thing. If the diagonals are 24 inches and 32 inches each. By the way, some of you may be wondering, what's a rhombus? That's what a rhombus looks like. It's a four-sided figure. It's a quadrilateral. And the cool little thing about a rhombus is all these four sides are going to be congruent. It means they have the same length. Now, you say, well, what does that have to do with the diagonals? Well, I guess we need to draw some diagonals in there and see what's going to go on. So at home, if you've got that rhombus drawn, go ahead and put it out there and let's see what's going to happen. We're going to draw some diagonals into our little friend here. And it's important to know it's a rhombus. Everybody keeps saying, well, I guess that's because all the sides are congruent. That's one option. There's something else going on here. When I draw these diagonals, lots of magic things happen. That's pretty nice, isn't it? First of all, notice what's happening as they're crossing, obviously. They're making what looks like a nice little plus sign almost, okay? And if you notice, they cross as perpendicular. They are perpendicular diagonals. That's what happens. It's one of the properties of a rhombus. The diagonals will be perpendicular. There's another thing about a rhombus. If you were to turn this thing sideways, if I did, of course, I would have just you be reading sideways, what have you. You would notice this is also a parallelogram because a rhombus is a parallelogram. It's a parallelogram with all four sides congruent. So while we're at it, let's go ahead and mark these little guys congruent. Now you say, well, Ernie, why are you telling us about the parallelogram business? Because there's a very important property of the parallelogram that's going to help us solve this problem. And that property is, that's what you're saying, there's got to be some more congruent stuff going on. Very obviously, I hope there's some congruent stuff going on here because these little guys right here are the same. That diagonal gets cut in half. And this little diagonal here is shining the same way. It gets cut in half. And basically, that's because there's a little property of parallelograms that say the diagonals of a parallelogram, not just any quadrilateral, but a parallelogram, will bisect each other. So we've got this nice little effect here. On top of that, my friends, guess what kind of triangles we got? There's a right angle. We've got a right triangle, and you know what we can do with right triangles? You got it. The Pythagorean Theorem, a squared plus b squared is going to equal c squared. My goodness, this is a great problem of all sorts of things going on. I haven't even put a number on the figure yet, have I? Let's talk about those numbers. But that's the first thing. You just got to understand what's going on with the rhombus. All sides congruent. See, once we get one side, all we do is multiply by 4, and we have what? Our perimeter. That's the first thing we notice. So that'll take care of us. If we can get to one side, we're good. Now, when I talk about these two diagonals, one is 24 and one is 32. Notice I'm kind of pointing at 24 being the shorter one and 32 being the longer one, which should make sense. What did I say about them? They bisect each other. So what does that tell me half a diagonal is worth? My goodness, what's a half a diagonal worth? It should be worth half a 32 maybe, 16. And what's this other little guy here? Oh my goodness, half a 24 could be 12. Now some of you out there, probably in some of those geometry classes, some of your teachers emphasize these things, I hope they do, called triples, Pythagorean triples. We have a Pythagorean triple here. It's coming off of a 3, 4, 5. But if you don't know the Pythagorean triples, that's okay. We can still work this problem out. And what we're going to do is we're going to call this an a squared plus b squared equals c squared moment. So here we have it, a squared plus your b squared equals c squared. You say, well, what's a and b? A and b are these nice little numbers 16. Remember, how did we get that? We took half of our 32. And what else happened there? We took half of our 12. So we get 12. We're going to square it. That was half from 24 that got us to 12. That's right. Everybody's good on that, right? Let's put a 16 in for b. Really doesn't matter which one goes where because we're going to square them and add them together. You're going to get the same answer there. And we have c squared hanging on for dear life on the other side. That's what we're looking for. Now, playing it out, I've got 144. I'm going to add 256. You know why? Because I know my perfect squares, my friends. You can go top 12 times 12, but you learned that one back in what, 3rd grade, 4th grade? So there you go, 144. And 16 times 16, Put that one in your brain, all right? 16 squared is going to give you 256. It's a nice number, really is. And on the other side here, we have c squared. Now, time to add a little bit. And when I add 144 plus 256, magical things happen. Well, they do, because this is what I said, it was a triple. So we're going to have 400, because that's what those two guys add up to, equaling to our c squared value. You say, well, Ernie, what's going to happen now? We want to know what c is. C squared is nice, but we're all about this length. What is this length? Which I guess it's going to be in inches, because these little guys are in inches, right? So we're right now in kind of square inch with some weird concoction here. So let's square root both sides. And we're going to go positive on this square root. Why? Because lengths have to be positive, right? So let's put a 20, because that's what 20 times 20 gives us, is 400. And square root of c squared, that's simply c. That was pretty straightforward, pretty easy, right? So basically, what do? We squared them, we added them, we took a square root, and we hoped it would come out even, and it did. Now, one more thing we have to do. What's the perimeter? Remember what I said? All sides are congruent, because this is a lovely rhombus. So we can put a 20 all around there. My goodness, you know what I see? 4 times 20, that's pretty easy, isn't it? Some of you like to add them up. You're still going to get the same amount. 20 plus 20 plus 20 plus 20. I'm going to take us for the perimeter to equal 4 times 20, which should be 80 what? Inches. Not square inches, but just 80 inches. And that, my folks, and that, my friends out there, everybody, that's your problem of the day. So I hope you got through it. Lots of properties going on there, but that's why in geometry you got to remember all those little things. But I'll give you a hint. If you draw this picture correctly, you can probably figure out a lot of the things that are going on there. If you really make a good rhombus, you draw great diagonals, you get that right triangle effect, you're going to see the splitting going on and on. That's why drawing pictures are so important, why it's great to have them and know what to do with them.